Good morning, everybody. Mr. Perez here. I'm just going over one more problem. So wanted to review the 815 additional practice part 2. Like it says, we're working with the area of regular polygons. Regular always means that the sides and angles are all the same measure. These questions are what you'll be reviewing, except the one that I'm going to do as an example, number 3, is actually a different number. So don't copy this down as your work for this question because the values we're working with are different. As it says here, this is a hexagon and we're trying to find the area. Since there is no equation for finding the area of a hexagon, or at least we don't have one, we need to break this one up into triangles. Just to go back to our notes, these are attached to the assignment as well. The way you find the area of a regular polygon starts with breaking it up into congruent triangles. So once you do that, we just got to focus on one triangle and find its area. That requires us to find the base and the height. If you see here on this question, we actually do have the height of the triangle that we're going to work with already. So if I were to break this off, this is the triangle that we're going to work with. And we know that there's 5 more, so 6 total of these triangles. Some things we need to know about this triangle, though, since we have the height, is we don't know what the base is, what this x is right here. In fact, I'll even change that to a b for base. So now that we know that this is our base and that's what we need to find the area, next step is working with some of the angles. Since this is a hexagon, we know that all the way around this is going to be 360 degrees. But there's 6 of those, so we know that this triangle up at the top, this measure, is going to be 60 degrees. That means that these two angles down here are also 60. The triangle needs to add up to 180 degrees. When we take away that 60, we're left with 120, and that evenly distributes to these two right here. So now that we have that kind of a triangle, we know that we can redraw it. Let me just redraw it right here. We have this right here, and then we have our height of 12. Since the top measure is 60 degrees, we know that this half of it is going to be 30 degrees. And the height right here makes a right angle at the bottom, which means that's 90. So there's 60 degrees left over right here. So again, we're just working with this one triangle and finding the base. The whole part of this black side is going to be the base, but we're only going to focus on this portion right here for now, since we can work with a right triangle to find that x value. So this x value is going to be found by using either trigonometry, or you actually could use the special right triangle relationship. Since this is the short side, the answer is going to end up being 12 divided by square root of 3, but I will show you the trigonometry version. So using this angle right here, that 60-degree angle, we can actually set up a ratio of tan of 60 and set that equal to opposite over adjacent, which is 12 over x. From here, we cross multiply, and we end up with x times tan of 60 equals 12 times 1. And then the last step would be to divide by tan of 60 and divide by tan of 60. So once we do that, x is equal to 12.1, or not 12.1, that's 12 times 1. X is equal to 12 divided by tan of 60. And let me grab my calculator. And that is going to be, since tan of 60 is the square root of 3, 6.93. So that means that that x value, this value right here, is 6.93. But we know that our base is twice as big. So that means that we need to multiply 6.93 times 2 to get our base. So that means that we end up with 13.86 as our base. So now we've got the value of our base, 13.86, and we have the value of our height. So we can find the area of one triangle. So it starts with finding the area of that one triangle, base times height divided by 2, which is going to be 13.86 times 12 all over 2. And that gives us 83.14. And we know that there are 6 triangles. So we end up with a final answer. Since this triangle right here is going to be 83.14, so is this one, this one, this one, and this one. All of them have an area of 83.14. Instead of adding them all up, I can just multiply the original one times 6, and I get my answer, which is 498.83. 498.83 units squared is the area of this hexagon. There are 6 triangles with an area of 83.14. So same idea applies to all of these other questions. Some of them are easier. The first couple, again, I'm not going to give you the answers, but the first couple are a little easier because you already have the height and the base and the height and the base for the question. So you just have to find the area of those triangles. This one, a little more difficult. You only have the height and you need to break it up into, since there are 3 sides on this triangle, you could break it up into 3 triangles. We know that this height is 9 over 2, but we don't have the base. If we were to go all the way around this right here, it's 360, but we know that there are 3 of these angles, and I'll mark them off with yellow. So we have the one angle right here, one angle right here, and one angle right here. Those are all going to be 120 degrees. So this is 120. When you break up the triangle like this, so that's just this part right here, we know that this is only 60 because the other 60 is over here. Then you can use trigonometry to find your base. So that is going to be how you find the base, but we also know that there is an extra base over here, so you need to add those 2. And the same idea applies to 5 and 6. I moved through that quickly. Let me know if you still have questions, but I hope that helps. And this will be something that you can review in preparation for the quiz that we'll have as well. All right. Thanks, guys. Have a good one.